Alright, well, welcome back to your favorite intermediate algebra course. We're going to talk about nth roots and rational exponents today with the objectives to, we're going to evaluate nth roots using some radical notation, exponential notation, use those nth roots to solve some problems here. So let's talk about real nth roots. So if you have n that's an integer, and your n's got to be bigger than 1 is also a restriction on that, and your a is any real number. So if n is odd, so we're taking the nth root of something, then a has only one real root um, if you're looking at the nth root of a. And again, n is odd here, and a can be any real number. So this first part right here, that's your radical notation, and the second part is your exponential notation. Okay, so the nth root of a is the same thing as a to the 1 over n, if you remember that. Um, and then secondly, if your n is even and a is positive, then you have two real nth roots. Okay, so if n is even, and we'll look at a couple of those examples here. Just a minute. So let's first of all, let's look at if we have an odd root, okay? So that first scenario that I was talking about. So let's let our n be 3 and our a be 64. So if we're taking the third root, that's a 3 right there, the third root of 64, that's the same thing as 64 to the 1/3, okay? So now we're looking for 3 of a kind underneath, aren't we, right? The third root, okay? So we're going to break that 64 down. We're like, well, 64 is 8 and 8, right? 8 and 8. Same thing as, so let's break that 8 down into 4 and 2. That other 8 down into 4 and 2. And actually, you know what? Let's combine those. So you see how we have 4, 4, and then with those, I have another 4. We're like, I got 3 of a kind, right? So the third root of 64 is 4. Or in other words, 64 to the 1/3 is 4. Okay? So let me extend this a little bit. Now you could also do the third root of, so here's a different example here. You do the third root of negative 64, right? Isn't negative 4 times negative 4 times negative 4 negative 64? Yes, it is. And you see how you have 3 of those? They're all the same there. So the third root of negative 64 is negative 4. So if you have an odd root, you just have one solution to that. Okay. Let's do another one here. Now let's take an even root. So let's say the fourth root of, let's say 81. Okay. So now we have an even root, fourth root, and underneath there, um, the so we're gonna, and the a value, that 81 there, that has to be positive. Okay, so we're gonna have two roots here when this pops out. So let's think about this. Let's break that 81 down. So we're like, well, it's 9 and 9. The 9, there's 3 and 3, 3 and 3, right? So we're like, oh yeah, okay, there is 4 of those. So our answer is 3. Now let's think about that again. Is there 4 of the same number that could also multiply to give you that 81? Couldn't we say, this fourth root of 81, couldn't we also go, well, isn't negative 9 times negative 9 positive 81? And let's see, how about negative 3 times negative 3, negative 3, and negative 3? Isn't that 9 times 9, right? That's 81. In other words, I have 4 of a kind. 1, 2, 3, 4. So negative 3 is also a root of this. Okay? So when you're doing an even root of a positive number here, another way to write that is 81 to the 1/4. Okay? You have to consider you actually have two roots. So it's plus minus 3 is your final answer. Okay? That's an even root there. Okay, so you have two solutions. Now, a lot of the time, You know, when we would do things before, like let's go just a square root, the second root of something, like the square root of 9, if they said, what's the square root of 9? And we would just say 3, right? 3 is called your principal root, your principal root. Okay, and so, but technically, you know, it's really plus minus 3 on that. Okay, but a lot of the time you're just like, ah, let's just go with the principal root and call it 3. Okay. All right, let's talk about some rational exponents here. Let me write this up. Rational exponents. So if you have, let's go with a to the m over n, okay? So this is, by definition, the nth root of a to the 1 over n times m. Okay, you remember how you would multiply that, a power, that m is your power of another power here, so you're multiplying those. If you multiply that, don't you get m over n there, if you will? Okay, so by definition, that is the nth root of a times m, or if you want to write it in radical notation, this is the same thing, right? So either one of those. So that's a to the m over n. Now what about if you have a to the negative m over n here, okay? And I'm considering m to be a positive integer, by the way. Okay, well this is 1 over a to the m over n, right? If you remember, like a to the negative 2 is 1 over a squared, right? So 1 over a to the m over n. Then we just apply that definition. We got a to the 1 over n to the m, okay? Or the nth root of a to the m, okay? So that's some rational exponents again. And a to the 1 over n being the nth root of a, n being a positive integer. So let's go ahead and look at, let's do some examples here, like 25 to the 3 halves. Okay, well, by definition, that's 25 to the 1 half to the third. Okay, and now you take that 25 to the 1 half. Now, you know how this is the square root of 25, 25 to the 1 half? And it's a second root, so it's an even root. So in all reality, you have two roots of this 20 of this square root of 20 of this 25, right? Plus or minus 5. But we're just going to consider the principal root here. Okay, and your textbook typically does that same thing. Okay, 5 times 5 times 5, 125. So we're not going to be overly picky on that one. Okay, 27. Let's do another one. How about 27 to the negative 2 thirds? Okay, 27 to the negative 2 thirds. Well, run that negative exponent definition. So 1 over 27 to the 2 thirds. Let me write that a little better. 1 over 27 to the 2 thirds, right? So that's 27 to the 1 third squared. So in other words, the third root of 27 squared. Okay. So we're looking for 3 of a kind. So we're like 3 of a kind. We're like, well, 27 is 3 times 3 times 3. In other words, the third root of 27. See how you got 3 of those? And I'm looking for how many? I'm looking for 3 of them. So the third root of 27 is 3. And I still got a squared at the end, don't I? So 1/9 on that. Okay. Now let's go ahead and solve some equations using these nth roots. Okay, so solving equations now. All right, how about this? 3x to the 6 equals 192. Well, again, you know, like we've always done, we're going to go ahead and isolate that x to the 6. So let's divide by 3. So x to the 6, let's see, what's that? 64. Okay. And now to get rid of that, x to the sixth, okay, we want just x, right? So we're thinking, well, what do I have to take this to get it to be x to the 1? I got to take it to the 1/6 power, both sides. Because isn't 6 times 1/6 6/6? Or in other words, x to the 1? You're like, sure it is, right? And so now we've got to just do this 6 through to 64. Okay? Now we have an even root here, and we're solving for variable x. So you have to consider both roots on this, okay? So plus minus. Just like if you were solving, x squared equals 9, and we square rooted both sides, and we always said plus minus 3, right? When you're solving the equations, you have to be technical about it and consider both roots on that, okay? So anyways, we break this 64 down, and we say, well, I'm looking for 6 of the same thing. Hopefully I can get it here, 8 and 8. And we're like, oh, 8 is 2 times 2 times 2, and that other 8, 2 times 2 times 2. Okay, how many do I got? Hey, I got 6. So this ends up being plus minus 2. Okay, how about this one? X plus 3 to the 5th equals 11. X plus 3 to the 5th equals 11. So what would you do on this one? You notice that your x plus 3, that entire thing is taken to the 5th, right? So you have to undo that 5th power by taking both sides to 1/5, right? And you notice if you multiply 5 times 1/5, you got 5/5, don't you? So x plus 3 to the 1. X plus 3 is now to the 1 power, isn't it? And then you got the 5th root of 11. Well, that's an odd root, so you only have one root on that, the 5th root of 11. And then, of course, we just got x plus 3 to the 1 power. And then we go ahead and we solve that and finish that off. So x equals negative 3 plus the 5th root of 11, or the 5th root of 11 minus 3. Those are not like terms, so we call it good. Or, if you want to, you can punch that into your calculator. You get about, let's see if I got it here. It's about negative 1.38. Okay. Let's do one more here. Let's go, about, let's get to it here. Let's evaluate a model with answers. Let's say the population of a certain animal species after t years can be modeled by, so you have this given equation. So the population P after t years is given by, C is your initial population here, 7 to the negative t over 3. Okay, so let's find the population after t years. So here's our population, okay? Here's our initial population, and t is time in years. Okay, t is our time in years. So let's find the population after 2 years. So let's find population after 2 years if initial population was, let's see, it says here was 1,000. 1,000. Okay, so let's go ahead and plug it in. We're like, hey, my initial population is 1,000. 2.72 times negative, and you put the t2 in there. Whoops. For your t, time, in years, okay? So 2.72 to the negative 2/3. And then we just got to punch this in. So we're going to punch in that part into your calculator first. So on your TI-89, when you punch that in, punch it in like this. This is your syntax, 2.72 to the, you got to put this in parentheses, negative 2/3. Okay, 2.72 to the negative 2/3, okay? And then at the end of that, then multiply it by 1,000, okay? So let me see what you get there for that. Hold on just a second, let me grab my calculator. Okay, looks like you get 2.72 to the negative 2/3, 0.513, and then we multiply that by 1,000. Of course, we get 513. 0.513 times by 1,000, 513, and that's 0.513201, by the way. We'll round that, okay? All right, thanks for listening.